we are going to see what are combination of errors. If we do an experiment involving several measurements, we must know how the errors in all the measurements combine. For example, if you are doing density measurement, and we know density is equal to mass divided by volume. If we have errors in mass, in the measurement of mass, and if we have errors in the measurement of volume, there is definitely error in the measurement of density, in the calculation of density. Okay, so to make such estimates, we should learn how errors combine in various mathematical operations. For example, in addition, in subtraction, multiplication, division, taking the powers, taking the square root, etc. Okay, for this we are using the following procedure. Number 1, we can say error of a sum or difference. Let two physical quantities A and B and the absolute errors associated with them are delta A and delta B. We know delta A and delta B are the absolute errors. Okay, thus the measured value in terms of absolute error can be represented as, how will you represent A plus or minus delta A, and in B how will you represent B plus or minus delta B. First, we wish to find the sum of the two physical quantity, that is Z is equal to A plus B. And delta Z be the absolute error in the measured value Z. Okay, so we are measuring Z is equal, we are calculating Z is equal to A plus B. Delta A is the absolute error in A, delta B is the absolute error in B, and delta Z be the absolute error in the calculated value, which is Z. So how will you represent the absolute error in Z? Absolute error in Z is delta Z is equal to delta A plus delta B. This is the method of finding the absolute error in the measured value, in the calculated value of the sum, error of a sum. So error of the sum is delta Z is equal to delta A plus delta B. Let Z is equal to A minus B. Now we can find out the error in difference. Okay, let Z is equal to A minus B. There also delta Z be the absolute error in Z. So how will you find out the absolute error in the difference? There also delta Z is equal to delta A plus delta B. Even if you are finding the sum of two physical quantity or difference of the two physical quantity, errors are only added up. We cannot subtract the error. Okay, if there is error in A and if there is error in B, there is always error in Z, if it is A plus B or A minus B. Clear, children? Okay, so if two physical quantities are added or subtracted, we have to take the absolute error, and the absolute error should be added up. Okay. Hence the rule is, when two physical quantities are added or subtracted, the absolute error in the final result is the sum of absolute errors in the individual physical quantities. This is applicable for both addition and subtraction. For addition and subtraction, take the absolute error and then just add the absolute errors. Okay. Question is, the temperature of two bodies measured by a thermometer are T1 equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius, T2 equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and the error within. So how will you find out T2 minus T1? We have to find out the temperature difference, isn't it? T2 minus T1. So 50 degrees Celsius plus or minus 0.5 minus 20 degrees Celsius plus or minus 0.5 degrees Celsius. So magnitudes are, these are the magnitudes, these are the original values. So magnitude can be subtracted. So T2 minus T1 can be written as 50 minus 20, that is equal to 30 degrees Celsius. These represent the absolute errors, isn't it? So we know that the error of a sum or difference, in error of sum or difference, the two physical quantities are added or subtracted, absolute errors of the final result should be added up. So errors cannot be subtracted, errors are added up. So what is the error in the difference? 0.5 degrees Celsius plus 0.5 degrees Celsius. So these are the absolute errors and the errors should be added. So magnitudes can be subtracted but errors are always added. So plus or minus, what is the error? 1 degree Celsius. So this is the method of finding error in sum or difference. Second one is error of a product or quotient. Suppose two physical quantities A and B and their absolute errors are delta A and delta B. Let we have to find Z is equal to A into B, product. Let Z is equal to AB. How will you find out the error in Z? In product or quotient, the error in the physical quantity, the measured physical quantity is, we have to take the relative error. That is, delta Z by Z is equal to delta A divided by A plus delta B by B. If you want to find out the error in Z, take the relative error of each physical quantity and take the sum. Clear? So, if Z is equal to A, B, or if you find Z is equal to A by B, for product and quotient, same rule. If Z equal to AB or Z equal to A by B, how will you find out the error in the value Z? That is relative error. Delta Z by Z is equal to delta A by A plus delta B by B. Hence, the rule is, when two physical quantities are multiplied or divided, the relative error in the result is the sum of relative errors in the multipliers. If two quantities are multiplied or divided, take the relative error and add the relative errors. Okay. Now, an example, the resistance R equal to V by I, where voltage V is equal to 100 plus or minus 5 volt and current is equal to 10 plus or minus 0.2 ampere. We have to find out the percentage error in R. R is the resistance. Okay. Now, we have to find out the percentage error. Now, we know that if for a product or quotient, just take the relative error and take the sum. Right. Now, what is the relative error? Here question is percentage error, no? So, what is the percentage error in R, delta R by R into 100? Relative error into 100 is equal to percentage error, equal to delta V by V into 100. That means percentage error in the voltage V plus percentage error in current, that is delta I divided by I into 100. This is the method. Okay. So, what is delta V here? Phi is delta V. Any physical quantity can be represented as A plus or minus delta B. So, what is A plus or minus delta A? Sorry, A plus or minus delta A. Any physical quantity can be represented as A plus or minus delta A. So, here delta A or phi represents what? The absolute error. So, delta V, voltage delta V can be written as V divided by 100. So, here in this we can substitute the values. Delta V, what is delta V? Phi. Phi divided by V. What is V here? The original value 100. Phi by 100 into 100 plus what is delta I? 0.2 divided by I. What is I? 10 into 100 is equal to, this one is 5%. This is, what is this value? This is equal to 2%. So, what is the percentage error in the resistance R? Delta R by R into 100 is equal to 7%. That is the answer. Okay. Third rule is error in case of a measured quantity raised to a power. For example, let Z is equal to A raised to N. Now, what is the error in Z? That is the relative error. Relative error in Z is equal to N times the relative error in A. Okay, so if Z is equal to A raised to a power, then the relative error in Z is equal to the power times relative error in that physical quantity. Hence, the rule is the relative error in a physical quantity raised to the power n is n times the relative error in the individual quantity. Okay. Example, find the relative error in Z if Z is equal to a cube b square divided by c d raised to 1 by 2. Okay. So, here it is an application of product as well as power. Now, we have to take the relative error, isn't it? So, relative error in Z is delta Z by Z is equal to, what is the relative error in A cube? 3 into delta A by A. Okay, plus what is the error in B square? 2 into delta B by B. Even if it is a division, we have to take the sum of relative error, isn't it? So, that is the rule. So, plus delta C by C. again plus what is the error in d raised to half 1 by 2 into delta d by d. This is the answer. This is the relative error in Z. So if it is a cube 3 into delta a by a, if it is b square 2 into delta b by b, c, that is error is delta c by a, c, and the error in d raised to 1 by 2 is half into delta b d by d. So take the relative error of all physical quantity and take the sum. Now we can do a numerical. A physical quantity P is related to 4 observables A, B, C, D as follows. P equals A cube B square divided by root C into D. The percentage errors in A, B, C, D are 1%, 3%, 4% and 2% respectively. Find the percentage error in P. This is the question. So how will you write the percentage error in P? Percentage error can be written as delta P divided by P into 100. That is the percentage error in P equals, what is the percentage error in A cube? 3 into delta A divided by A into 100 plus then B square, what is its percentage error? 2 into delta B by B into 100 plus what is the percentage error in root C? That is root C means 1 by 2, C raised to 1 by 2. So half into delta C by C into 100 plus percentage error in D is delta D by D into 100. Okay, we can substitute the values equals 3 into what is the percentage error in A, that is 1%, plus 2 into what is the percentage error in B, that is 3%, that is given. Okay, plus what is the percentage error in C, that is 4%. So 1 by 2 into 4% plus delta D by D into 100 is 2%, that is 2%, is equal to 3 plus 6 plus 2 plus 2, that is equal to 13%. So percentage error in the physical quantity P equals 13%. Question. For a simple pendulum of length 50 cm plus or minus 0.1 cm, the time period of oscillation is 50 seconds when observed using a stopwatch having resolution of 1 second. Find the accuracy in the determination of G. Given time period T equals 2 pi into root of L divided by G. Here the time period is given by the formula T equal to 2 pi into root of L by G, isn't it? Here we have to find out accuracy in the determination of G. Accuracy in the determination of G means we have to find out the percentage error in G. Okay, so we have T equal to 2 pi root of L divided by G. From this, how will you write G? We can just square the equation. Squaring, we can write T square equals 4 pi square into L divided by G. Okay, so G can be written as 4 pi square into L divided by T square. So this is the formula for G. We have to find out the accuracy in the determination of G means we have to find out the percentage error in G. Okay, so percentage error in G can be written as delta G by G into 100 equal to 4 pi square is a constant. So there is no error for them. So it can be written as, what is the error in L? Percentage error in L can be written as delta L by L into 100. Okay, plus since it is quotient division, we have to take relative error, or we have to take the percentage error and take the sum. That is the rule. So percentage error in L is delta L by L into 100 and percentage error in T square is 2 into delta T by T into 100. Okay, is equal to, what is delta L? Delta L here in the question itself it is given delta L is 0.1 centimeter because the original length is 50 centimeter plus or minus 0.1. So delta L is direct 0.1 divided by what is the length? 50. Clear? Into 100 plus 2 into what is delta T? Here the resolution of the stop clock is 1 second. So delta T, that is 1. Okay, that is actually the least count error. Least count error in the stop clock is 1 second. So delta T is equal to 1 second. Divided by what is the time? Time is 50 seconds. time of oscillation is 50, that is also given in the question, into 100. Okay. Here 0.1 into 100 divided by 50 equal to 0.2 percentage, plus here it is 4 percentage. If you take the sum, 4.2 percentage. So percentage error in acceleration due to gravity g, or the accuracy in the determination of g, is answer 4.2 percentage.